test.
Oh, sorry. Hello? Okay, so sorry about that. Didn't get audio on those. But so there's two real-world cases that you can have here. From an offensive perspective, if you have created a piece of malware that you're going to use on a red team engagement, you are going to want to test that against a number of AV scanner engines and keep doing that until it is not caught by any of the AV scanners. Also, there is the defensive, from a defensive perspective, if you have a binary or you have a file that you believe to be malicious, but that file might be a doc, it might be a PDF, and it might be targeted to your organization, you don't want that specific piece of malware to get out into the world. You don't want other organizations reverse engineering it and understanding that you might have been owned. You need to do damage control. It may have sensitive information about your organization in it, so you don't want any of that to be disclosed out to just a website that you don't know who else is looking at the data that's on there. So, and I wanted to scare you into seeing exactly what a real-world example of this use case is, because this is about a month and a half ago, I found a set of files on one of those online scanners. And these files were all part of a family of malware called ursnif. And so the ursnif malware family searches your drives for PDFs, and it looks for just every PDF that you have on your hard drive, and it infects each one of them. It changes them a bit so that it becomes, the name of the PDF, pdf.exe, so most people should notice that as like a little bit of a warning sign that there's something wrong with the PDF. But you'd be surprised, some people just it doesn't click, and then they click it. So it infects every PDF that it finds, and then you see the PDF that you thought was some flyer or the instructions for your router or whatever like that, and you see the thing that you thought was a clean PDF, and then you email it to someone, and then they receive it, and maybe something tips them off that they should probably send that to some online scanner engine, and so they upload it, and then game over. You can have you've just lost your data out to random people on the internet. So bad things can happen in that situation, and I wanted to give you an example of exactly how bad that can be. And these are, so I'm going to give you, these are actually all redacted versions of some files that I have found online. So this is one which is this is a certificate of analysis of a chemical of some type. And then there is the back of a check, and it has, some company's information on there. I don't know why someone would scan their checks and keep them on their hard drive. That's a little baffling. But this is the receipt for someone's car repair. They went and had their BMW X5 repaired, and this is the bill for all the repairs. This is a packing list of something that was sent to some guy. And then here is the front and the stubs for a check. This is another check. You're getting the picture. You don't want this type of data to just get out into the world, because who knows what people can do with that. And there's no reason for that to happen if you can keep it under control. So, and also there's a couple other projects that I wanted to kind of like point out, and they they basically create malware that is less detectable or undetectable. So Veil framework, I don't know if anyone's heard of this, but I spoke at ShmooCon in January, and one of the guys from Veil was speaking right after me, and we chatted, and they said that my project is basically something they've needed for a while, and they were going to do it themselves, but now that I've got code that I'm going to be releasing later today, I think they may actually give me a little help. So Backdoor Factory is another one where you take a binary and patch it to add backdoors to it. So where did I come up with this idea? Some of you may recognize this bar. This is Shutters at the Rio at DEF CON. This is not actually DEF CON. Those guys are not hackers. But this was where I came up with the idea with a group of other people. During DEF CON, we were bouncing ideas off of each other, and I realized that there was a gap in the area of open source software that provides this type of capability, because you only have online scanners, or you have closed source on-prem super expensive scanners. So it was just a ripe area for a project to be created. And so one of the things I was trying to think about is why is it that no one had decided to create a project like this? And I think the only reason I could come up with is that most people who are deep into open source software tend to shy away from closed source software, so they don't want to write something that basically orchestrates a whole lot of closed source software together. It just doesn't, it's not the first thing that occurs to someone who's into open source software, but as a security person, this seems completely logical to me. So what are the basic PlagueScanner components? And the list on the left, so I've given this talk a few times already, and I've changed this slide a bit. So the list on the left is the stuff that's in PlagueScanner and will be released today. The stuff on the right is stuff that I'm still doing a little bit more work on, and I'm giving a talk next week in Paris on PlagueScanner, and hopefully I'll have a few more components from that side, which I can move over here for more code releases. But the basic components, it's built with Python 3. All the modules that I use are Python 3 modules. The core of PlagueScanner uses FreeBSD. There are certain scanners that don't have a FreeBSD version, so if they have a Linux version, I have to use Linux in that case. Some of the scanners are only Windows, so I have Windows boxes that also. And I use a combination of 0MQ and Nginx to transmit the jobs to each one of the scanners. And I'll go over why in a minute when we get to some later slides. But basically, I was originally using 0MQ only, and it occurred to me that it's 0MQ is not necessarily designed to transmit files, even though there is a client file MQ. So what I'm doing is using 0MQ to send the messages, and then I have an Nginx server with the malware on it, and then each one of the scanners picks up the malware using just an HTTP get of that piece of malware. And so Nginx is designed to be very, very, very fast, and so it definitely cut a lot of the problems out at that point. So I use VirtualBox or virtualization. I was supporting QEMU for a while, but I think I just want to stick to one virtualization, one type of virtualization, rather than supporting more than one. So I've chosen VirtualBox. It has a feature called page fusion, and that's memory deduplication, and I'll get into that in a moment as well. My report format is JSON, so that you'll be able to ingest the report into just about anything that you can think of. And then you can also throw it into Elasticsearch, MongoDB, any sort of NoSQL database. And then on the scanners, I'm using a YAPC plugin system, and this is just basically to make it easy for an end user to create a plugin without having to really know Python and code a lot of extra components in Python that are outside of just the processing of that scanner. So there's an Elasticsearch report, and this is basically taking the full JSON report and then jamming it into Elasticsearch so that you could do visualizations using ELK. And then the last part here is something I still haven't gotten to work yet, but it's the OCR of some of the scanners. It is a really tough thing to get to work, and if anyone has any ideas for it, I'm open for suggestions. So the point is, you bring the scanners, so you have to go out and get these are closed source products, so you have to go and buy the licenses. I'm not involved with that. I might even have some lawyer's letter in my mail saying, hey, why are you reselling or getting involved with our product? So no, you get the scanners, that's up to you. Same thing with the Windows licenses. Please make sure that just like any malware analysis system, make sure you've paid for your licenses. Don't just use unlicensed copies of Windows. And then at the other side of it, we bring the plugins. So the goal here is that I would like to have plugins for each AV scanner engine so that I'm at least at parity with the famous online scanner engines. So in previous talks, I'd actually, from looking at lots and lots and lots of scanners, I had categorized them previously into 4 categories. And since my last talk at B-Side Salt Lake, I have actually split them into 5 different types of scanners. So the first type of scanner is open source, and there's only one. It's ClamAV. We all know that one. And then the second type is a scanner that has a Linux version. And if it has a Linux version or a BSD version or a Unix command line version, it's very, very easy to pull into and use the data and use the scanner in Python and use the scanner in PlagueScanner. So the third type is a Windows-only scanner. There's plenty of these. There's actually more of them than there are Linux scanners. But this third category is a Windows-only scanner, but it has a command line so that you can, you can run, subprocess popen, subprocess call in Python, and call the binary and use it just like you would one in Linux. Now, the last 2 categories are the really difficult ones. So category 4, these are the category 4 and 5 are ones that I have just recently split into 2 separate categories. So it's the type of scanner, number 4, which has a GUI, but they have coded the GUI properly so that it has accessibility features. So if you're aware of Windows accessibility features, this is for if you are blind, you need to be able to basically read with a Braille terminal or something like that what's on the screen, and so the data that's in that pop-up window is accessible to them. So number 5, this category are the scanners that don't code that and just that information is not there. So category 5 are the ones that I need to have OCR for. So OCR, like what are you talking about? Why optical character recognition? So if a scanner is in that last category, there's no way for me to get the data out of that scanner other than taking a screenshot and then running OCR on it, and then taking that data and then running the regexes on that. So it's not 100% working, so what's my next option? So the next option here, and this is something that I do need help with because I'm not a Windows programmer by any means. So there's a program called inspect.exe, and this is part of the Windows 8 SDK, and you can find it in Windows 8.1 SDK. This is the one that I've actually pulled out. And it lets you view any UI elements accessibility data. So at the point I'm at now, because I've been recently started working on this feature, is I can see the data. I just need to know how to programmatically get to it. So this is a screenshot of inspect.exe. And if you select a UI component like that, you get to see all of the, all of the accessibility data involved in that UI component. So how is my architecture designed? It's actually super, super, super easy and super simple. So up at the top, this is the submission processing and reporting node, if you will, and I'll show you all of this, in a demo in a moment. The message queue in the center is 0MQ, and so I'll go into detail about what the messages look like and how they're constructed. And then on the left, on your right, this is a Linux VM where I'm running the Windows VMs inside of it, and then each one of those VMs inside of it is running a bridged adapter, so that from the perspective of the submission node, they all look like just nodes that it can send data and receive data from. And then the Linux VMs, and each one of these has an agent which is tailored to the scanner that's installed there. I'm working on this component. I'm working on adding the plugin, the YAPC plugin manager, so that people don't have to remember which agent to install on which one. They just install one package and it has all the plugins, and makes it much easier to install. So what are some of the really cool features here? So as I said earlier, Page Fusion is a feature of VirtualBox, and so what it does is if you have 4 VMs, all of them running Windows 8.1, many of the memory pages are going to be exactly the same across all 4 of those VMs. And so why would the host, the hypervisor, keep a the host operating system keep each one of those memory pages when they should only keep one, and then have that shared across each one of the VMs? So that's what it does. And it allows you to run quite a few different VMs in one system and share all the same memory, and not waste a whole bunch of memory. So if you have 1 gig, you've assigned 1 gig of memory to your VM, and you've got 4 VMs, you're not going to take 4 gigs of memory for the host operating system. So that's pretty cool. 0MQ is a very, very fast message queuing. I'm pretty sure everyone's familiar with something like RabbitMQ, but this is just a little bit faster, and it has no broker. So there's just the client server. There isn't like a broker that the message has to go through to get to its endpoint. And then Elasticsearch, it's basically just a free text search engine. You put data into it, and then you can index the data and do searches and get back interesting, emergent information about the data, and then you can do visualization through Kibana. So there's a few open issues that I have with the project. So the first open issue is Docker, and so I'm trying right now to get the virus scanner engines, the Linux virus scanner engines, into Docker containers. And the reason for this is to have them all run on one host rather than have them run on multiple hosts. So rather than wasting the resources of having multiple VMs, one for each Linux-based scanner engine, I would have one host and then a Docker container for each of the scanner engines. Basically reducing the amount of overhead and resources involved. I still need to get OCR working. And then also the core, PlagueScanner core is just a script, so it runs, sends out the messages, sends out the malware, waits for a response, creates the JSON document, and then dumps it for you. So that is something I want to create a daemon, in a similar way that like Cuckoo Sandbox, where you can submit jobs to it and then you wait, and then you could submit multiple jobs to it. And then another thing, and I've had questions a lot about this, is scanner updating. So scanner updating, there's just like the different types of scanners, scanner updating to make sure that things are updated and that they're updated when you run it. It's actually very easy on the Linux side and ClamAV. I can use Python to deterministically know that those are updated, and I include the update and the version data in the JSON output of PlagueScanner. So those are easy. Making sure that the Windows scanners are updated is a little bit more difficult, and this is an open problem, just figuring out how to make sure that all of the Windows scanners have updated themselves before something is run, or at least on a regular basis. And then also, one of the things I want to do is have resubmission automation. Once I have a daemonized core, I want to have resubmission automation. And the reason for this is, let's say you have a binary that is not detected at all. You know that it's malicious. You've begun reverse engineering it. You've begun doing further analysis on it. But you may not yet know what it is. So you would want to automate a resubmission, every hour, every 2 hours, 3 hours, whatever it is, whatever your choice is, so that when it is finally detected, you'll get a result, and you might be able to shortcut some of the malware analysis stages where you're trying to figure out, like, if it's a specific malware family, and the scanner will give you a hint as to which family it is. Sometimes not. One of my pet peeves with a lot of the scanners is from the scanner company's perspective, because they're a business, they're trying to make money, so they're trying to reduce costs, and it appears that they would rather have a generic one generic signature that kind of covers many malware families, rather than having lots of smaller signatures that are tuned for one family. I think developing lots of signatures, when you're from that perspective, there's less cost for making a generic that covers more ground. But for someone like me, I would rather have a specific signature that tells me what family that is, or at least approximately what that is. Some of the scanner engines are good about that, like they're very specific, and some of the scanner engines just come back, yeah, it's cryptic. This one is ZBot. They're all cryptic or ZBot or generic. So those are not necessarily as valuable as other scanner data. So this entry down here, HP feeds, I don't know if anyone is familiar with HP feeds, but this is a publish-subscribe protocol. And the HP feeds, it's a HoneyNet project, which you are probably familiar with. So what HP feeds does is it allows a instance of PlagueScanner, or an instance of Thug, which is a Honey client, or an instance of Cuckoo Sandbox. It allows you, as the person who's not running that, to subscribe to a feed of the data that's coming out of that Cuckoo Sandbox, or that Thug instance, or whatever the thing that's producing the data is. So you could maybe get a feed of binaries. You could get a feed of the output data. Lots of different things that you can do. And then there's also a website. It's called HP Friends, and it's sort of a Facebookish social media kind of thing, where everyone's a researcher, and then you're trading your HP feeds connections with each other. So I would love to get an HP feeds plugin, output plugin in there. And then lastly, if anyone is a Windows programmer, let me know. I need help in that department, because I need to get the accessibility data out of the accessibility features, and then into basically just into text that I can process using Python. So I want to just take a quick look under the hood and show you a little bit of the code that is running here. This afternoon, check out my GitHub site. At some point today, that I will have done a push out there, so you can see this yourself, and hopefully start helping me with it. But one of the things I was kind of proud of was I actually got threading to work finally. Threading is actually, it's fairly easy to do in Python, but sort of the mental game of figuring out, like, what is threading really doing with my data, and how are these interacting together? That can be a little bit more difficult than just a linear, serial script. So this is what I'm doing here. I've got a worker which takes. So I have the queue builder, which is actually off the screen down at the bottom. But the queue builder just takes the scanner's IP address, the scanner name, whether Bitdefender, ESET, ClamAV, whatever, and then the port, and creates a tuple, jams that in there as an item in the queue, and then the worker just pulls out the next one as threads are created, and then sends it to this function here, send to scanner. So send to scanner takes scanner IP and file name, and then goes and creates the message that gets sent to each one of the scanners. And then earlier, before this, I'm actually taking the file that we want to look at and creating a temp file in the directory that Nginx is sharing. And so while all of the threads are still running, that file is available in the directory on Nginx. And then as soon as all of the threads have come back and finished, that file is actually removed because I'm using Python temp file. So as soon as I close the file handle, Python itself cleans everything up. It's all gone. So I don't have to worry about cleaning anything up myself. And then this is the Nginx booster that I was mentioning. So this is where I create the file here using temp file, and right here, this is actually what I just talked about. So this is where we've got the file being dropped into Nginx's www directory, and then and that's the outbound samples directory up here. And then it generates I don't have to generate a random file name, so there's no way that anything will conflict with another file name, because Python handles creating those random file names itself and making sure they're not going to collide. And then as soon as down here, so this is where the data gets jammed into the queue, the work queue, and then at the end of that, when the work queue is finished, after all the threads have hit the join method, then I close that file handle, and then boom, everything's cleaned up and I'm done, and then I'm dropping a JSON document into the standard out. So this is from the other end. So these are on the nodes that the scanners are running on, and so this is the file scanner. I use subprocess popen. Some of the scanners will take piped input, so I'm able to use the communicate method for subprocess popen and give it a piped data, so that I never have to actually create a file on the file system. I'm taking a bytes.io object, and then reading from the bytes.io object and writing that data directly to standard in. And so some of them are able to do it that way. Some of them aren't, and so this is one that is not. And so again, I'm using a temp file here, and so the temp file only exists during the time that the scanner is scanning it, and then when everything is done, when I close that file handle, it also cleans everything up. For all of these, I have them, so every scanner has some form of quarantine. So I want to turn off quarantine. I don't want to I don't want to have files just building up on the file system on the scanners. I want to keep keep it easy to maintain. So no cleaning, no quarantine, nothing like that. And so then once I've got that, I basically just have a pile of text, which is the scanner has told me, lots of different information, like its version and its name, and who its children are and who its parents are, and then what the malware is or what it isn't. A lot of times, the scanner is not going to find what the malware is, and so it'll just come back with none. And this is the part which takes a little fine tuning, just going back and figuring out where in that blob of data is the stuff that I want, and I want to carve out and like put into my JSON document that's the final product of PlagueScanner. So I pull all that data out, and there's a different parse output function for each scanner. So this is something that's different for each scanner, and this is what's going to live in the YAPC plugin. And so I want to talk about the PlagueScanner message format. So 0MQ allows you to send a message to your subscribers, to different sockets, like however you have it configured. And so I have it configured with a send. I'm sending a string, and so the response that I'm getting back from the scanners is actually JSON. So I'm doing a send JSON, receive JSON from the reply, but the message going out, the request, is just a string. And I've kind of created my own notation here, and it's the command scan. And there will be a few more commands as I grow this protocol, if you will. But right now it's scan, and then you have the scanner name, and then at the end is the file name, and the file name is the temp file name that Python has created and dropped into the Nginx outbound directory. So this is an example of that file name. I just pulled this one from one that I was scanning last night. And so the scan Bitdefender, and then that is the temporary file name that was generated by Python. So let's do a demo. And I didn't want to tempt the demo gods too much, but I do have a live, as long as the network is running and still like being happy, I can connect to a live one. And I've got malware queued up here, so if you have any requests for malware that you want to scan, let me know. But I'm going to go with the recorded demo first, just so we can see what it does, and I know that it's not going to, die on me or have a problem. So this is just this is a simple version of this is a simple kind of reduced feature set of the whole thing. So on this side, this is the core, and this is where you run the PlagueScanner.py script. And then these are three of the agents that are running over here, just so that you can see. You wouldn't actually run them this way, but I'm running them this way, and I have a print command in there just to show you the message as it arrives and what the message looks like. And also because so if anyone has seen some of my previous presentations, it was serial, so it was just one single threaded, and so we'd have to wait a while, and I had to compress it. But you'll see now, because of the threading, it's like bam, and you'll see them all hit at the same time, which is pretty cool. So the first binary that I'm going to show you here is teamviewer.exe. It's not TeamViewer, by the way. So as you can see, it's scanning those. It's being scanned, and then after a moment, the slowest scanner is the one that's the problem. So as you can see, so ESET comes back and says AlenaOS.f. Bitdefender's like Zeusy, which is like, that's like Zbot. They're like, we don't care. It's generic. And then ClamAV, awesome. They've got exactly what it is, Alena 3. So this is a point-of-sale malware that I was working on last week. This is a fresh sample. And this is actually, it's a segue and for me to talk to you about the techniques that they're using. So they, a lot of the POS malware kind of herders that are out there, the users of the malware, are using credential phishing for things like LogMeIn and TeamViewer, and then they're using TeamViewer and LogMeIn and that sort of thing as the theme, sort of the theme for how they get into your organization. So things like Find POS, Alena, and so they're kind of combining. Rather than having a very targeted attack at some place where that there's point of sale malware, they're doing shotgun blast of spam, and then hoping, you know, that the binary that you hit, that they, you know, that they get to infect out there, can then pivot and find malware. I mean, find a POS system that's on the network that it's gone to. So, and you know, it's interesting, that kind of technique. I'd think, oh, that's not going to work too well. But you'd be surprised how many people have kind of paused their POS and then used the, you know, because it's Windows POS software, and then they pop up a web browser, and then all of a sudden, they're, you know, I can read my email here because this is a web browser. So they might be reading their email on, you know, a cash register system, which is not a good idea ever. But, you know, it could happen. And so these people, the people that are behind these strains of malware, are hoping for that type of mistake to happen. So let's keep going here. And the next one that we're going to do is, let's see, sample.exe. So sample.exe, this one is a copy of ersniff, one of the ersniff examples that I went over earlier. The reason I called it sample.exe is because even the file name had information about that company that I wouldn't want you guys to even see here. So as you can see, it came back with basically some nonsensical answers. Nobody picked it out as ersniff. Up here, ESET picked it out as cryptic. So if you're used to scanning things with scanners and working in malware, cryptic is another one of those generic. It's not actually cryptic. So here, and then at least Bitdefender said, yeah, generic. We don't know, whatever. And then this next one, 77kb.bin. There we go. So, and as you can see, it gets shot alt to each one of the scanners all at the same time, which I was actually very proud of. I was like, I got threading right finally. So this one is a dropper. So, you know, they haven't been able to tell me exactly what it is. I'm getting back at least one generic here, but they're telling me that it's a dropper. So this is good information. This means that I need to go, this means probably the people that wrote this signature have watched it go either download a piece of malware and install it, or, you know, basically pull it out of one of its resources, kind of pull the malware out of its pocket and like install it on the system. So now I know when I go and do an analysis of this binary, I need to look for another file that gets dropped. And so I need to figure out what that other file is. And that other file is typically a different malware family. So, you know, it could be dropping Zeus, probably. It could be dropping a POS malware. It could be dropping all kinds of things, Dire, whatever. But at least I now know that this is a dropper, and I need to look for another file. Next one. Remove wat226.rar. I don't know about you, but I don't open or use anything that has rar as a file name anymore. I think it's all malware by now. So as you can see here, I don't know what this is, but ClamAV has pulled it as hacktool.crack.wpa. So chances are this is not as malicious as other things. This is probably one of those gray area tools that we all use every day, but get flagged as malware for some reason or not. You know, so you know, this would warrant maybe a bit more information, but it could mean that you know, it could mean that if you find this on one of your endpoints, that you've got you know, a pen tester or an adversary that has gotten in and they're doing something live on that system. So who knows? And then that's the end of my little video here. And I think we have like 5 minutes left or so. And do we have any requests for malware? So I'm going to go over here to malware, which is the this is Cuckoo. This is an online version of Cuckoo Sandbox. If you haven't heard of it, go visit it. It's malwr. .org or .com. I'm in presentation mode, so I can't go see that. But I don't know, any of these that you want to take a look at, any malware families you can think of. Any questions about PlagueScanner? No, I can. It's PlagueScanner. Just type in PlagueScanner at GitHub, search for PlagueScanner, and it'll be under the username PlagueScanner, and then the project will be also PlagueScanner. You can't miss it. You'll see. The frog will be the. Cool. Awesome. I didn't even have to do any like search engine fiddling for that. It's a very good question. So one of the reasons why for here I had I have 15. I'm planning on releasing 5 today, and I'm going to release 10 more next week, just because I'm giving a talk in Paris, and I wanted to have a little bit more code to release there and not just get rid of all of it today. So, but yeah, there's 15 scanners. They're the usual set. Off the top of my head, I can't remember all of them, but you've got AVG. I know AVG, WinDefender, ESET, Bitdefender, ClamAV, Avast, Viper, and a few more. But yeah, so I want to. My goal is to have like the 50 plus that are, so I'm parity with all the other, scanner banks. So at the moment, it uses quite a lot of resources. So I'm assigning. I've assigned 1 gig of memory to each one of the VMs, and so with kernel same page. Sorry, that was what I was using before. With Page Fusion, the overhead. I mean, I have assigned it. I've got a 16 gig. This thing has 16 gigs, and I am pushing it with having 16 gigs. So. Yeah, that's an area that I do need to work on, getting the resources and overhead fixed. Right. So the first question, which was about, sorry, could you repeat? The first one was. Right. So they don't. That's up to you. I of course, like any good programmer, I haven't gotten to the documentation yet. So, but the documentation is going to be basically for the scanners. I'm going to basically link and say, this is the version of the scanner that you need to use. And if you want to use a different one, then just contribute the code for how to instrument that one. But I'll point to the documentation. I'll at least help you find, because some of the scanner engines don't have the best documentation and located in the best places. So I'll make sure that you get to their documentation. I'll basically carry you to their documentation and say, if you follow this, when you are done following this set of instructions from them, you then begin with my set of instructions here. And then, do you have to choose all of them? No. So let me give you that question I can answer best by looking at what's in here. So this is the configuration file. So here, I've got ClamAV, ESET, and Bitdefender are the ones over here. And, essentially the only thing you have to do to tell it to use or not use them is just comment out that section of the config file. So. Yes. So each endpoint is a manual update if it is Windows. If it is Linux, those are the Linux ones that I've got. I'm working on Komodo. Komodo's weird. I've got it working, but it just doesn't have. I haven't found a piece of malware that it can find a result for. So, but so those all I've got them fixed up so that it makes sure that they're updated. But the Windows ones, it's just a lot of them just run on their own, and they check on their own. So I have to figure out a way to maybe force that or. Next question. Okay, very good question. So the main reason for doing that is I'm hosting. So I have my cloud hosting is at Rackspace, and they're actually very nice to open source projects. They give you a budget every month of service, and so the reason I'm doing that is all of my scanners are on Windows 8.1, and there's no copy of Windows 8.1 that you can load from. It's not one of the VM options at Rackspace. So I'm getting around that by loading up one Linux VM, which is an option, and then having the Windows 8.1 VMs inside of it. If you have a way to get a Windows 8.1 running on one of their cloud instances, I think it's actually against the terms of service for workstation versions of Windows, but next question. All right. Well, thank you all. Thank you. All right. Drop the mic.